Yes, can you hear me, Jaslyn and Zeba?
Yes, ma'am.
Okay. So who will tell me how many theorems we did in the last class? Right, so we have discussed some properties of parallelogram in the previous class, right? First of all, we discussed that there are three types of quadrilaterals. One can be a trapezium, other can be a parallelogram, and the other can be a kite. Is that clear?
Yes, ma'am.
Okay. Then parallelogram can be of three types. It can be a rhombus, it can be a rectangle, it can be a square. Is that clear?
Yes, ma'am.
Okay. Then we were discussing the properties of a parallelogram, right? So what was the first property we discussed? So we were saying that diagonal divides into two congruent triangles, correct? In short, I'm writing. You have already written that, right? The second property we have discussed, opposite sides are equal. Is that correct? Right? And the third one, opposite angles are also equal. So in any parallelogram, opposite angles are also always equal. For example, if I take a rhombus, so opposite sides are equal in length. Opposite angles are also equal in length. So that means this angle is same as this angle, right? This angle will be same as this angle, right?
Yes,
Okay.
ma'am.
Fourth property we discussed, right? Any two consecutive angles are supplementary, right? That is the sum is 180 degree. So if I take angle 1 and angle 2, so angle 1 plus angle 2 is equal to 180 degree. That is the meaning. And the fifth important one, that diagonals bisect each other, right? So if I draw the diagonals of this parallelogram, so they divide each other into two equal parts. Is that clear? I mean, this is very common that opposite angle equal, opposite sides are equal. This you can remember. And this is also important that the diagonals bisect each other. Is that okay? Okay, then its converse is also true, right? That if the opposite sides of a quadrilateral of a parallelogram are equal, if the opposite sides of a quadrilateral are equal, then it is a parallelogram. Understand? So we don't call it parallelogram in the starting. In the starting, we call it a quadrilateral, right? So if the opposite sides of any quadrilateral are equal, then it is a parallelogram. This is the converse. Is that clear? Similarly, the converse of this property is also true, that if opposite angles of any quadrilateral are equal, then that quadrilateral is a parallelogram. Is that clear? Seba, is that clear?
Yes, ma'am.
Okay. And plus, this converse is also true, that if in any any quadrilateral, if the diagonals are bisecting each other, then it is a parallelogram. Jaslyn, is that clear? Okay, then let us start with exercise 8.1 of NCRT. Let me just open it. Okay, there's one more theorem I left. After that, we will start the chapter. Sorry, exercise. Just 1 minute. Yes, there's one more theorem. Let us do that first of all. A quadrilateral is a parallelogram if it's one pair of opposite sides are equal and parallel. Understand? See, so far we have learned that if all the opposite sides are equal, then it is a parallelogram. Is that clear? Now please reply yes or no. Jesslyn, I can't hear you today. Please unmute yourself. I think there's some problem with your audio. Jesslyn, please check it, okay? Now Zeba is also facing network problems. Anyway, she'll join. You listen. See, so far we were saying that if all the opposite sides of any quadrilateral, let's say I have a quadrilateral here, ABCD, right? I'm not calling it a parallelogram, I'm calling it a quadrilateral, right? So we know that if any quadrilateral, the opposite sides are equal, that means AB is equal to CD and AD is equal to BC, then I can say it's a parallelogram, right? But if only one pair of opposite side, that means AB is equal to CD, right? If any one pair is equal, and I say that AB is parallel to CD, then also I can say that it is a parallelogram, right? I don't require the another pair. Only one pair has to be equal and parallel. So two conditions have to be satisfied. Is that clear? So this proof can come in the exam. This is important theorem. Now what is given here? ABCD is a quadrilateral, right? So we have to show that it is a parallelogram. So we write it a quadrilateral. And one pair of side is equal. So AB is equal to CD and it is parallel. So AB is parallel to CD. This much is all given. Now we have to prove that it is a parallelogram. So we have to prove that ABCD is a parallelogram. Right, Jocelyn? At least you can type if you can hear me. Okay, so before proof, there's a construction here. I mean, we have to make some triangles. We don't have any triangles, so we join one diagonal. Join AC. Okay, fine if you can hear me. So I hope it's clear, right? What we are trying to do. Now let us do the proof. Yes, Jocelyn. Okay, Zeba is also here now. Zeba, can you hear me?
Yes, ma'am. Actually, due to network. So,
Okay, so this is an important theorem. Now see here. See, so far, Zeba, we know that in any quadrilateral, if opposite sides are equal, it is a parallelogram, right? Or we say that opposite sides are parallel to each other, it's a parallelogram. Is that clear?
yes, ma'am.
But in this theorem, we are saying that it's not necessary that both the side have to be equal and parallel. Now, in any quadrilateral, if any one pair of side are equal and parallel, if they satisfy the condition, then also it is a parallelogram. Clear?
Yes, ma'am.
So ABCD is a quadrilateral. We have to show it's a parallelogram. So we write it a quadrilateral. And this is given that one side AB is equal to CD and it is parallel to CD. And we have to show that it is a parallelogram. Correct? Okay. So we have joined AC. Uh, see, what is the approach here? Mm, if I just name these angles, for example, I take this angle. We just see here. Okay, let me name them. Let's say this is 1 and this is 2, this is 3, this is 4. Just name the angles, right? Okay. So we use a theorem here. Now try to understand what we are doing. Now in this quadrilateral, this side is already given that it is parallel. Is that clear? Now if somehow we show that the other side is also parallel, so then we can say it's a parallelogram. We can use the previous theorem that all the opposite sides are parallel. Yes. So basically our objective is to show that AD is also parallel to BC. Is that understood? Don't write, just try to understand. Is that clear? Say yes and no at least. Yes? Okay. So we will try to show that AD is parallel to BC. Now to show AD is parallel to BC, now see here. This, if we use the converse theorem, for example, these are two parallel lines, okay? And this is a transversal. Is that clear? Now, if we show that this angle is equal to this angle, so if the alternate interior angles are equal, then the lines are parallel, isn't it? We have done that in the chapter lines and angles. So there are two theorems basically. First of all, if the lines are already parallel, so we say that the alternate interior angles are equal, right? And its converse is also true. That if alternate angles are already equal, so we can conclude that the lines are parallel. Is that clear?
Yes, ma'am.
Yeah. So basically, we will try to show that angle 2 is equal to angle 4 so that we can say that AD is parallel to BC. Is that clear? Right. Now, angle 2 and angle 4. So basically, they are part of triangles ABC and ADC, correct? So if somehow we show that this triangle is congruent to this triangle, so by CPCT, we can say angle 2 is equal to angle 4, right? So the first step is to show that the two triangles are congruent. Is that clear? So we take
Yes,
these two triangles. So in triangle ABC and triangle ADC. Now come on, who will tell me what is equal to what? Tell me three things here. Something is already given, isn't it? Come on. In these two triangles, one thing is already given. Use it. That AB is equal to CD, isn't it? Then I can see a common side. AC is equal to AC, which is common, right? This is given. Now, one more thing I need. I have got two sides. So another side or another angle. So another side is AD, which actually I don't know. So I will look at angles. Which angle is equal to which angle here? Zeba. I told you, you always have to use the given conditions. So one condition we have already used, right? Now look at the second condition, how you can use it. So the line AB is parallel to line CD, clear? And there's a transversal which is cutting it. Is that clear?
Yes, ma'am.
So that means this angle is equal to this angle. Yes,
Yes.
alternate interior angles. So you can say, you can write like this, since AB is parallel to CD, so that implies angle 3, no, ABC. So first of all, write angle 1 is equal to angle 3. Why? They are alternate interior angles. So which condition it becomes? It becomes SAS, right? Two sides, one angle. So by SAS criteria, uh, triangle ABC is congruent to triangle ADC, right? And by CPCT, we can say that angle 2 is equal to angle 4. Understand?
Yes, ma'am.
So see here, now what is happening? Let's say these are the two sides, right? And this is a transversal which is crossing it. So now 2 is equal to 4. That means, this, okay. So this angle is equal to this angle. Again, they are alternate interior angles, right? This is A, B, C, D. Okay, so this is your side A or B and C, D. Now look at it like this. Now this angle 2 is equal to 4, right? This I have got. So by the converse theorem, I can say that the lines are parallel. Thus, AD is parallel to BC. Yes.
Yes, ma'am.
Or you can write like this before this. So far it's clear. Angle 2 is equal to angle 4, right? And AC is a transversal. So if you look at it like this, that AC is a transversal and angle 2 is equal to angle 4. So therefore we can say that AD is parallel to BC. Okay. Now you come back to the original quadrilateral. Now what is happening? So in quadrilateral ABCD. Now what is happening? See, this is ABCD, right? So AB was already equal to CD given. Now we have also proved that AD is also parallel to BC. Okay. Now since opposite sides are parallel, so there's a theorem that in a parallelogram the opposite sides are parallel, right? So since opposite sides are parallel, therefore ABCD is a parallelogram. Yeah, okay. Not only parallel. Okay, you have learned that opposite sides are equal, right? So from CPCD, we can also say one thing, that the side AD is also equal to BC. I mean, the length is also equal, right? Because we have shown that these two triangles are congruent. Is that okay? Please say yes and no. Okay.
Yes, ma'am.
Okay, so this is an additional thing. Please write. We have also shown by CPCD that this AD is equal to CB. Okay, now what is happening? So AB is parallel to CD and AB was already equal to CD, that was given. Now we have shown that AD is parallel to BC and AD is also equal to BC. So the opposite sides are parallel and equal. So therefore ABCD is a parallelogram. So the theorem was basically that the opposite sides are equal. So by the converse, ABCD is a parallelogram. Now let us come to exercise 8.1. I hope you have written it.
Yes, ma'am.
Okay, so the angles of a quadrilateral are in this ratio. Find the angles of the quadrilateral. So I told you that when anything is given in the ratio, so you take it like that. 3x, 5x, 9x, 13x. Is that clear? So let A, B, C, D are the angles. Is that clear? Of the quadrilateral. So basically what is given, that A is to B is to C is to D. This is equal to 3 is to 5 is to 9 is to 30. So we cannot say that A is equal to 3, B is equal to 5. No, I have discussed it before also. So we say that let A is equal to, 3x, B is equal to 5x, C is equal to 9x, and D is equal to 13x. Is that clear?
Yes, ma'am.
Okay, it's because it's the ratio which is given, not the exact angle. Right. Now we know that the sum of the angles of a quadrilateral is 360 degree. I have discussed it, right? Have I discussed it? I think I discussed it in the starting. The angle sum property it is called, right? So the sum is 360 degree. That means 3x plus 5x plus 9x plus 13x is equal to 360 degree. So you add it, what you get? So you get 13 plus 3 is 16, and then 5 21, and 9 30. So you get 30x is equal to 360, right? 0 0 cancels out. Okay, x is 360 divided by 30, right? So that becomes 112 degree. Is x is equal to 12, right? 12 degree you can say, because it's degree, right? Okay, so only x we have got, not the angles. So therefore the angles are, so one by one we will find out. So A, which is equal to 3x, That means 3 into 12 degree. So that means 3 into 2, 6 and 36 degree, right? Now B is 5x. That means 5 into 12 degree. So 60 degree. Then C is 9x. So it is 9 into 12 degree, which is 9 into 2 is 18. Carry 1, 9 into 1. So 108 degree. And D is 13x. So that is 13 into 12 degree. I think it will be 156 if you multiply. Yeah, because in my previous class I multiplied 13 into 12, so I remember it was 156. You can check. And also you can check, like for your satisfaction, that the sum has to be 180 degree, right? It's not necessary to do in the question. For your satisfaction or in the rough, you can check that the sum has to be 360. So you will know whether you have found the right answer or not. So 6 and 6, 12 and plus 8, 20. Carry 2. Right? 6 and 5 is 11 and 5. That becomes 16. And that becomes 360. Right, Seva?
Yes, ma'am.
Okay, I hope you have written. Next question now. Yeah, okay. So if the diagonals of a parallelogram are equal, then show it is a rectangle. So there's a parallelogram. We have to show it's a rectangle. So we can draw it like a rectangle, but we are not saying right now that it is a rectangle. Okay, we have to show it. So A, B, C, and D. Now the diagonals are equal. So you join the diagonals AC and BD. Let me call this point O. So what is given? You write here. So it is a parallelogram. Already it is given that it is a parallelogram. Now see this term clearly, right? Parallelogram means we can use all the properties of parallelogram here. Is that clear? If it is written that the diagonals of a quadrilateral are equal, getting it? So that means we cannot use the properties of parallelogram because we don't know whether it's a parallelogram or not. So you pay attention to what is written in the question. Clear? So ABCD is a parallelogram. This is an important thing which is given. So we can use all the properties, all the theorems of parallelogram. Okay, and the diagonals are equal. So AC is equal to BD. This is, sorry, BD. This is also given. Now to prove that it is a rectangle. So ABCD is a rectangle. Now, first of all, tell me, we discussed about rectangle, right? It is one of the kind of parallelogram. Okay, so what exactly you have to prove here? What are the features of rectangle? First of all, it has to be a parallelogram, clear? That means AB side should be equal to CD side and AD side should be equal to BC side, right? And also the AB side has to be parallel to CD and AD has to be parallel to BC. So it becomes a parallelogram. Is that clear? Now this much is already given in the question. It is already said that it is a parallelogram. So what is the extra thing you have to show here? Will tell me. What is the difference between this figure and this figure? Now here also I'm saying that AB is equal to CD, right? And AD is equal to BC. So what is the difference you can see? How I cannot say that it is a rectangle? Zeba, come on, speak up. Okay, she's not here. Jesslyn, what is the difference between figure 1 and figure 2? Can you tell me? See, Zeba, the only difference is that this angle is not 90-degree, right? In a rectangle, I told you one of the angle has to be 90-degree. This is the additional thing, right? So it has to be a parallelogram plus one of the angle has to be 90-degree. Is that clear? So basically, we have to prove that one of the angle of this parallelogram is 90-degree. I mean, any angle, angle A, angle B, C, D, whichever you want, one of them has to be 90. Is that understood? Right, Zeba? Jesslyn? Now also, before starting the proof, now try to understand one thing. Why I'm saying only one angle? See, if only one angle is 90, now see here, P, Q, R, S. Just try to understand, don't write. Now I'm saying that angle P is 90 and it is a parallelogram, right? I'm saying it. Okay. Now we know in a parallelogram, the opposite angles are equal, right? So that means angle R will also be 90. Okay. Now we know again in a parallelogram that any two consecutive angles are supplementary, right? That means angle R plus angle Q is going to be 180-degree. This is already 90. This is 180. So angle Q will be 180 minus 90, again 90. So it will also come out to be 90, right? And again, the opposite angles are equal. So angle S will also be 90. So we don't have to show all the angles 90. If any one angle we show 90, the other three will also come out to be 90. Is that clear? So that is why we focus only on one angle of the parallelogram, not all the angles, because all will ultimately be 90-degree. I hope it's clear. Okay. And let us do the proof. See, we can do one thing. If I take these two triangles, let us say this. One of the triangle is this ABC. Can you see that? And the other triangle I'm taking is this CDB. Is that clear? First of all, let us try to prove that they are congruent. Then you will see what we will do. So in triangle, so in triangle ABC and triangle, okay, you can write to prove ABCD is a rectangle, or for your understanding, you can write that angle B is 90-degree. Any one angle is 90-degree, right? Okay, in triangle ABC and triangle BCD. Why I'm writing angle B? Because I'm taking this this side of triangles. So I'll get angle B 90, not angle A, right? For angle A, I have to take the left side of triangles. Okay. ABC and BCD. Now, it is already a parallelogram. That means the opposite sides are equal in length. Okay. So I can say that AB is equal to CD. Is that clear? Opposite sides of a parallelogram are equal, right? And BC is equal to BC, which is a common side. Now, what else do I have here? So in the question, it is already given that the diagonals are equal, right? So this side AC is equal to BC. BD, sorry, it is given. So I have all the three sides equal. So by S congruence, I can say triangle ABC is congruent to triangle BCD. Is that clear? Right? Okay. Okay. So now by CPCT, I can say that this angle will be equal to this angle. Right? So by CPCT, now I can say that angle ABC will be equal to angle DCB, or angle B is equal to angle C. Correct? So this much I have got. You can call it like equation number 1 because we will use it. Okay. Now in a parallelogram, we know that any two consecutive angles are supplementary, right? In a parallelogram, any two consecutive angles are supplementary. This is a theorem that we know, right? So we can say, therefore, angle B, angle ABC and plus angle DCB is going to be 180 degree. That clear? This is ABCD. That means this angle plus this angle. They are consecutive angles, right? Now, because they both are equal, so I can replace one angle. So I can say, or angle ABC plus angle ABC is equal to 180 degree. Why? From 1. I have used the result 1, that they are equal. So I get twice of angle ABC is equal to 180 degree, right? And that gives me angle ABC equal to 90 degree. So this angle I have shown to be 90 degree. Right? So I can conclude. So now we can say that ABCD is a parallelogram, which is already given. It's a parallelogram with one angle 90 degree, right? So therefore it is a rectangle. Therefore, ABCD is a rectangle, correct? So for rectangle, now please note, you have to satisfy two conditions. First of all, it has to be a parallelogram. Second, the other angle, the one of the angle is 90 degree. Same for square. You have to show that it is a parallelogram plus one angle 90 degree. I hope you will remember. So in case of square also, you will do the same thing. First of all, it has to be a parallelogram and one of the angle 90 degree. Same for rectangle, it has to be a parallelogram plus one angle 90 degree. Yes, Jocelyn, written. Okay. Now one more question we can take up. We have time. Okay, Jocelyn, now look at the question. Show that if the diagonals of a quadrilateral bisect each other at right angles, right? Then it is a rhombus. So now try to understand first of all, don't write. Let's say you have a quadrilateral. So it's just a quadrilateral, right? I'm not saying that it's a parallelogram, correct? It's a quadrilateral. Let me call it ABC. It's a rough figure. Just try to understand first of all. And now I'm saying that if the diagonals bisect each other at right angle. So first thing I'm saying that they are bisecting each other, right? So that means this part is equal to this part and this part is equal to this part. And also I'm saying that all these angles are 90-degree, right? Okay. Then I have to show it is a rhombus, right? Now, what is a rhombus? First of all, rhombus is a parallelogram, correct? Now, if you remember, now look again. Rectangle, right? Plus square and rhombus. First of all, they all are parallelograms. Is that clear? Yes? Okay. Now, in any question, if any as I told you, if any quadrilateral is given and you have to show it is a rectangle. So first step is you will show that it is a parallelogram, right? And plus one angle 90-degree. Understood? Similarly, for square, first thing you will show it is a parallelogram plus one angle 90-degree. And now, if you will leave here, so what will be the difference between a rectangle and a square? So there is an additional thing that you have to show that all the sides are also equal. Is that clear? You can note it down. I mean, this is important. So you have to show the three things for square. Now, similarly for rhombus, first of all, you will show it is a parallelogram. Now, in case of rhombus, this angle A is not 90 degrees, so you don't have to show. But you have to show that all the sides are equal. So this thing you have to show. So AB is equal to BC is equal to CD is equal to AD. So ultimately, in this question, you will do these two things. First of all, you will show it's a parallelogram. Secondly, you will show that all the sides are equal in length. Is that clear? You can write this. This will help you. So maximum number of things you have to show for square. You have to show three things, okay? If it is already given that it's a parallelogram, just show it's a square, so you can skip this. I mean, it's already given. If it is given it's a quadrilateral, so first of all, you have to show it's a parallelogram plus one at one angle 90-degree, and all the sides are equal. Is that understood? As in question number 2, it was already given it's a parallelogram. So only one step we did. That angle, one of the angle 90 degrees. So it's a rectangle. I hope you understand now. Let us do the question. Right. So question number 3. Let us draw a proper figure now. So it's just a quadrilateral. So I'm not drawing it like a rhombus. If you want, you can. No issue. Or you can, okay, make it a little bit like a rhombus. A, B, C, and D. Now these are the diagonals. Please join it. This is O. And like all these angles are 90 degree. So what is given here? ABCD is a quadrilateral, right? So it is just a quadrilateral. Okay. But it is given that the diagonals bisect each other. That means AO is equal to OC and BO is equal to OD. This is given. And also one of the angle is 90 degree, right? So let's say angle COD is 90 degree. See, if one angle is 90, all the other will be 90, that you can see yourself. Why 90? All the other angles? See, I told you in the chapter lines and angles, whenever you have an X, right? Opposite angles are equal. So if this is 90, this is 90, correct? Now, angle 1 and angle 2 are linear pair. So if angle 1 is 90, angle 2 is also 90. Is that understood? Sorry, something opened here. Okay. So I hope, Zeba, it's clear. Jaslyn. Okay, to prove that ABCD is a rhombus, right? Now proof. Okay, now we take two triangles. Which one? I take this AOB, right? And I take AOD. I mean this one and this one. Is that clear? So in triangle AOB and triangle AOD. So I'm trying to show that they are congruent, right? So first of all, I can see AO is a common side. AO is equal to AO, that is common, right? Okay. Now it is given that this side is equal to this. I mean, the diagonal is divided into two equal parts. So I can say that OB is equal to OD, right? It is given. And also like this angle is equal to this angle, both are 90 degree. So angle AOB is equal to angle AOD, 90 degree each. So I have got SAS criteria, right? So by SAS, I can say that triangle AOB is congruent to triangle AOD. Is that clear? So by CPCT, now I have got that this side is equal to this side. So I can say that side AB is equal to side AD. Is that clear? Yes, Jocelyn, is that clear? Okay. Now see, I have taken these two triangles. Now, second time I can take these two triangles, right? So I'll not do the whole thing again. I can write similarly. So for this and this. So similarly, I can say that side BC will be equal to CD. That's it, right? Just 1 minute. Okay, so there's a problem, Jocelyn. Now, what is the problem here? Okay, let us finish this question. See, Jocelyn, there's a problem here. What is the problem? Now, see here. Pay attention. When I took these two triangles, right? These two. So I have got this side to be equal to this side, right? Now, if I take these two triangles, so this side is equal to this side, it will come out. But how will I say that all the four sides are equal? Getting it? So I'm getting AB is equal to AD, right? And I'm getting BC is equal to CD. But from here, I cannot say that AB is equal to BC is equal to CD is equal to AD, right? I cannot say that. There's an issue, correct? So there's an additional thing I have to do. So one by one, I'll take. If I just name the triangles, let me call this triangle 1, triangle 2, triangle 3, and triangle 4, right? So basically, first of all, I took triangle 1 and triangle 2, right? And similarly, if I take triangle 3 and 4, right? So 3 and 4, if I take, so I will get BC is equal to CD. Is that correct? Okay. Taking 3 and 4 triangle, I mean, for your understanding. Now, if I take triangle 1 and 4 side by side, this triangle if I take, and I show that these two are congruent, so I'll get AD is equal to CD, right? Now you look at these three conditions. This is 1, this is 2, and this is 3. Now you write one by one. So first of all, I'm writing 1. So AB is equal to AD, right? Now AD is equal to CD from 3. So equal to CD, and CD is equal to BC, right? So now I'm getting all the four sides of the quadrilateral to be equal. I hope it's understood now. Yes, Jocelyn? So we write that So first of all, you see here in this figure, all the sides are equal. That means the opposite sides are also equal, right? So in quadrilateral ABCD, how I named it? ABCD. ABCD, right? The opposite sides are equal. From here, I can conclude from this, right? Opposite sides are equal. Is that clear? So that means it is a parallelogram. It implies it is a parallelogram.